All right, welcome again to section 8, week 4. Yeah, today we're going to be talking about pandas for data analysis. As you can see on the title, as the title of this class, right? But before we go into pandas, we would actually have to wrap up with NumPy. So we were unable to finish up with NumPy yesterday, so we're going to just quickly go over that before going to pandas, right? So I want to believe everyone has, at least most of us, usually read ahead of the class, right? Um, actually a very good practice. So the concept will not be entirely new to you, but that is why we make provisions for some of these things we drop on the Google Classroom, all these materials. For example, the recommended textbook that I posted on the Google Classroom some weeks back. So it's just there, so you can always read ahead. You can always look at what we are doing right in the next class and read ahead. So it will help you. It's actually going to help you with understanding the concept better, right? So you also have the curriculum, that is the data science curriculum. And everything there, everything is highlighted there. It is actually all the things we're going to be covering over the course of this program is on the curriculum, so you know what to expect each week, and you can prepare ahead um, for each class, right? So that is it for that. I just want to encourage us to try and read these textbooks, right? Read these materials that I post. Yesterday, I think I posted. Okay, I think it was today. I dropped a particular material, two materials on Google Classroom. I don't know how many of us have seen it. They are actually cheat sheets, right? They are cheat sheets for NumPy cheat sheets. So I did this for Python operations the other time we did Python. So I'm doing this now for Python. This cheat sheet is actually is some summary of most things you'll be needing in NumPy. It's like a single page summary of every function, the concepts, just those important points, right? So you can just open the cheat sheet. Is a PDF format, and you can just go through it. You can always use it to make reference, like to anything. Let's say you are trying to remember a particular function in NumPy. So instead of going through, or maybe it's just something you need to remember quickly. Instead of going through the textbook and going to watch videos, you can just quickly open the cheat sheet and just glance through it and see, okay, this is a particular function for this. So it is just a very, very good thing to have. So I dropped that in the Google Classroom. You can see it. You should have seen it by now, right? If you got the notification, right? So that is it for that. Just encouraging us to get conversant with these materials, right? So it's not just the class that you'll be depending on. Right? I make sure I say this every single lecture. So you have a responsibility to learn to on your own, right? So I'll be going straight to the for going straight to what we have for today, right? We continue from where we stopped yesterday on NumPy, and then move on to pandas. So the recording for yesterday's class is already available. I've dropped the link on the Google Classroom. So for those of us that were not in the class, you can always go back to it and just watch and practice, and those concepts that probably those of you that were here yesterday but you didn't get everything, you can still go back to it, watch the video, and yeah, have a better understanding of what we did. So I'm going to be sharing my screen now. All right. So please, can you confirm if you can see my screen? Please confirm if you can see my screen. All right. Great. Perfect, perfect. So we continued with NumPy yesterday, right? Um, we talked about last week. We introduced NumPy. So we talked about the basics of NumPy, the what NumPy arrays are. I gave us an assignment on that. Right. So yesterday we all right. So yesterday we continued with array manipulation. So we talked about basic operations in NumPy and also array manipulation. So if you're not in the class yesterday, you can um, always go back to the class recording and yeah, to gain a better understanding or to catch up with the whole thing. Right. So today we'll be continuing from where we stopped. So now we'll be looking at what we call aggregation functions in statistical operations in NumPy. So now we are now entering working with data. Right. So the essence of this course is to teach you how to work with data. Right. So we've been teaching you the tools and Python and all those stuff, right? But now we are now beginning to enter data analysis, right? So now in NumPy, there is what we call aggregation functions, right? So aggregation functions. So what exactly is aggregation functions? So aggregation basically is combining something, combining a list of values. First of all, aggregation is can only be performed on numerical data, right? It can only be performed on numerical data. So because aggregation is usually has to do with okay, we'll get to that, right? But so aggregation is basically bringing a list or combining a list of values and squeezing them into a single value. So let me repeat that. So aggregation basically mean combining a list of values into one single value. So you have, let's say you have a list of values like let's say like 100. So if you perform aggregation on those 100 values elements, you're going to end up having one element, right? You're going to end up having one element. So that is what aggregation is. So there are functions that can help you to aggregate values in NumPy, and yeah, you would get to understand why we use aggregation functions and when to use aggregation functions as we move on. So aggregation is a very important part of data analysis. Now we are entering data analysis concept. So aggregation is an important aspect of data analysis, right? So that sometimes you are trying to get a summary of your data, right? Okay, for example, you want to get the mean of a particular variable. Let's say you have a variable, age variable. Like let's assume we get the age variable of everybody in data science class, right? So we want to get a single value that will tell us something about the age variable for everybody. So we don't want to look through all the all the we don't want to look through all the values for every single student in the class. So we want to use just one value to get an understanding of what the age looks like, right? So that is where aggregation comes in. Aggregation kind of squeezing everything to one meaningful value. So for instance, you can use the average. You can get the average of all the students, the average age of all the students. So if you get the average, or if you use the average operation on the age variable, you are going to end up getting one single value. So that one single value is going to be the average, right? It's going to be the average, and the that average is actually the aggregation that you are performing on your age variable. So that is an example of an aggregation function. Average, right, is an example of an aggregation function. We also have sum, like we also have sum. So for instance, you want to you have a business, right? Right, and you usually take note of how much you make in a day, or how much how much sales, how much you sell per day. So you have them in your Excel sheet, right? You write the product name and then the price and everything. So and basically you have your data as a business person and you want to get an idea of how much you've made so far, right? How much you've made so far. So it's not going to make sense going through all the it's not going to make sense going through all days individually, trying to see how much you made each day, right? And start calculating it or start trying to make sense out of it. It's not going to, it's going to be very, very exhausting. Like, it's going to be very tasking to do that. And our brain is not wired to understand things that way. So the best way to understand how much you've made so far is to get an the sum of all the sales you've made so far. Let's say it's for a month or for a week or for a day or even for a year, right? So the best way to do it is to use an aggregation function. And in this case, you use sum. So sum, that is addition. Sum is going to add all the how much you've made for each day, and it will sum it for all the days that you've sold something or all the days that you operated into one single value, right? And that one single value is the aggregated value. So that is basically what aggregation is. Aggregation is combining a list of values to give you one meaningful single value that you can make sense of. So I've mentioned two kinds of aggregation functions. Now I've mentioned your mean, your average. I've mentioned sum. So there are other ones that you're going to see in the course of this program, right? So you'll be using this as a data scientist, right? So this is something you need to understand, right? So in this section, let me move on, right? So we would explore the fundamental aggregation functions and statistical operations, right? So we're also going to be doing some basic statistics, right, to help us understand our data, right? So NumPy actually provides some of these aggregation functions that would help us understand data and aggregate them well. So we are just going to look at it here, right? So let me just quickly go this. Okay, so we are going to look at the common aggregation functions we have in NumPy, right? So as you can see here, aggregation functions are used to summarize or reduce the data contained in an array to a single value, right? So these functions are essential for data analysis and statistical computations, right? So now let's just quickly, I don't want to waste much time on NumPy because we have pandas to look at today. So we are going to just look at some data, right, as we always do. I'm going to create a new notebook, right? Yeah, and just I posted my rough sheets. When the notebook I used to give examples in my classes, I posted it on the Google Classroom. So one of you made mention of that it would be helpful, and I was like, okay, no problem. So you can always go to the Google Classroom and you see under each session you see the example or this particular notebook I use for example. So you can just kind of have a better understanding of what we've done or what we did in the class, right? So now, first things first, what are we going to do? I want to use NumPy. What am I going to do? I need your feedback, right? I open my notebook and I want to do something with NumPy. What am I going to do? Okay, let me just say, I'll create a variable. I'll create an array, right? Is this the first step? Like, all right, perfect, exactly. So don't forget it. Like always import your NumPy, right? It is not built into Python, so you have to import it from where it is. Like let's say you want to talk to somebody, right? And that person is sleeping. So if you go near to the person and you start talking to the person while the person is sleeping, the person will not answer you. Like it will be like you're just saying rubbish, right? So it's same thing for Python. Like you don't talk to NumPy, you have to wake it up. Oh yeah, NumPy, wake up. And the way to wake NumPy up is by importing it, right? So not just for NumPy, every other libraries we're going to be using, you have to wake them up. Let me just use that word. illustration, you have to wake it up. And the way to wake it up is by using the import function. So we'll say import NumPy as what? NP. So this NP now is called what? I like going over what we've done before, so I would know how much you guys are following me. So NP here, what do we call this? What do we call this? Exactly. We call it alias, right? Alias. It's an alternate name for NumPy. It's like nickname. Exactly. It's like a nickname. NP is like a nickname for NumPy. So that is what we call it. But the main the what we call it in Python is an alias. So let's just have that at the back of our mind. Right. So now we import NumPy, and what we wanted to do is, okay, I can come here and say, let me just comment and say import NumPy. Right. All right, great. So what I want to do, I want to use aggregation, using aggregation functions. All right, so let me just create a list of values. Let me say array. I can say np dot arrange, right? I can say, let me say 10 to 70, right? So I can just do this. Okay, I've not run this cell yet. So I can just do this. So I've created an array now. If I print it out, I'm going to get this. So these are a list of numbers. So let's just assume this is the list. This is the list of student scores in a class, right? So you wrote an exam, or you are a teacher and you conducted an exam for your students, and at the end you had 60 students, and 60 of them had these scores. So you want to understand the statistics, or you just want to summarize the score to understand, to get information about the scores, right? So you can get the average. An average is a very good way to understand what the center point of your data, right? So averaging your data is a very good way to have an idea or summarize your data. So, and this is you can only perform it on numerical variables. So as I said before, aggregation functions, they are usually performed on numerical data, right? So now let me start with the okay, the first one here. We are going to be doing np dot, okay, average aggregation. So now I have this list of values, right? So I want to aggregate them using average. So I can just come here and say array np dot mean, right? np dot mean, and I'll put my array here. So if I run this, I'm going to get this 39.5. All right, so I've aggregated, what I just did now is that I've aggregated this entire data to a single value here, 39.5. So what is 39.5 means that 39.5 is the average of all these things. So average is basically adding all these things together, all these numbers together, and dividing it by the total number. So if we add 10, 11, 12, 2, 69, we'll get a particular value. So let me just quickly do that. Okay. Let me do that. So let's assume I want to add all these scores together now, right? So I will use another aggregation function to do that. So an aggregation function to add all your values together in NumPy is addition, basically, right? But the way the function in NumPy is sum, np.sum. So now there's something I want to point out here. Remember when we're doing element-wise operation, let me go back to this and see if I can see that. When we're doing element-wise operation, we had np.add, right? As you can see, it's np.add. It is not the same thing with np.sum. This np.add what is a universal function. And if you remember what I said, a universal function is used for performing element-wise operation in NumPy. It doesn't aggregate, right? So a universal function, this np.add will require you to have two different arrays that you want to add together. But this np.sum, let's come here. So np.sum here, right, is different from that. It is not a universal function. It is an aggregation function. It carries or it accepts only just one particular array, and it aggregates that array. It adds all the value in that array to give you one value. So that is what it does. So don't it can be confusing sometimes because add and sum, they are basically technically the same thing, right? But they are used differently in NumPy. Note that difference, all right? So because it can be easy to confuse. So now we already have sum. So if you come here and say array and we run it, we're going to get 2,370. So that is the sum of all the values here. So we basically added everything, right? So if we let's use that add now. Add. You see, to give us an error, but add takes 3 exactly. So we're going to use sum instead to aggregate our data here. So I can say array mean is equals to this, and I can come here and say print average of array is equals to. You can also see how I use string formatting a lot. It helps you to have an understanding when you are printing out a particular thing. And I told you, remember I told you when we're discussing on string formatting that you'll be using mostly F string, right? Like you'll be using mostly F string. So the other two methods are just there for you to know, right? But this F string is the most straightforward and the simplest, right? So that is just it. And let me just create this variable array dot array sum. Yeah. So that is we'll print sum of array equals to array sum, right? So if we print this, here's what we're going to get. Average of the array is what? 39.5. Sum of the array is what? 27 point, I say 27 point, 22,370. So now I just want to explain what average is. Like, I believe everybody here knows what average is, but let me just still explain it, right? So now average is combining, adding everything and dividing it by the total number of elements we have. So in situations where, let's say you want to use an alternate way and an alternate method to get the average, you can simply get the sum first and then come here and say the length of your array is. Now there's a function in Python that tells you, or that would tell you how many elements or values you have in a particular list or array. So it is len, L-E-N. Yeah, so L-E-N. So if I put the array there and I run it, it should give me a value 60. So one thing you have to know in Python is that every day you will be learning new things, right? There are a lot of functions in Python that I cannot teach you everything. It's not even possible. Even I myself, I still discover some new functions in Python. So even people that are way experienced, they still discover new functions every day. So the functions in Python, they are way too much. So you keep learning and you keep learning and you keep learning, right? So now I'm introducing another new function to you, which is len, L-E-N. I don't know if I introduced it before, right? But I don't know if I've introduced it, but I can't really remember. But for the sake of this particular operation, we are going to be using len. So what this len does is that it outputs the length of an object. So in this case, the object is an array, right? The len is actually the number of data or the number of elements in that array. You can actually use different methods to get the len, right? You can actually use array dot size, right? Remember we did sorry, array is not just r. Remember we did this when we were talking about the attributes of NumPy. You can use array dot size, right? It will give you 62, right? You can use array dot shape. Array dot shape will give you 60, right? Because it's a one-dimensional array, comma. So now to get this particular 60, you can just index it, right? And say 0. So now this, what I just did here now is that this array dot shape, it returns a tuple. This is the tuple here. It returns a tuple. So you can actually index that tuple, right? You can index that tuple. So I can come here and say 0. So the value at the 0th index is what? 60. So it has just one value and just one index. So if I index it to 1, it's going to give me an error because it's just one value. I say tuple index out of range, right? So just follow me. There are a lot of things I'll be introducing as we are moving on, and it builds on the previous knowledge you already have, right? So now we are just going to say array.shape 0. Yeah, let me correct that. So what array.shape 0 will do is that it will pick out only that 60, right? And it will output it for you. So I have given you now 3 ways of getting the length of an array. The first one was the built-in Python len, len, right, array. The second one, array.size, and the third one, array.shape.0, right? So these are 3 ways of doing the same thing. So that is one thing I like about Python. So even if you forget one, you can always remember the other one, right? So basically what I'm trying to do here is just to get the length. So I can just assign this to a variable or any of them. I can just say array len is equals to this, right? So now to get the mean of this manually, I'll just come and say array sum divided by array len. Right, so if I run this, I'm going to get the same thing, 39.5. So that is what is happening here in this mean, right? It is basically summing up all the values and dividing it by the total number of values or elements. So yeah, we are now advancing, right? We are doing quite some advanced stuff at this moment. So please just try to pay attention. So this is aggregation, right? We just did aggregation using mean, that is np.mean, and np.sum. So there are other aggregation functions, right? We have mean, we have max, right? We will also look at other ones. We have median, we have standard deviation, we have variance, right? So what all this thing does is that it takes all the value and imputes just one particular value, right? So that is basically a regression function. So if we just give an example, use the other ones as an example, you can see getting the minimum and maximum values of our array. So let's assume what you want to do now. You have a list of data or your student score. Let's use your student score, and you want to know what the lowest score is, right? You want to know what the lowest score is. So instead of you to manually just go to this particular data and be going through all of them one by one, you can easily just use the NumPy aggregation function, or np, that's np.mean. Right, so what np.mean is going to do is going to take all the value and just look at the one that is the minimum, right? It will compare it with there are actually I don't know exactly how it does it, right? But it does it goes through all the values and brings out the minimum value. So, right, if you put our array here and say np.min, it will output 10. So you don't need to go through the data to check. You just once you see 10, you say, well, 10 is so there was a student of mine that scored 10. So you can now, based on this information, you can now be bothered. So is it that they didn't understand the concept, or is it that I didn't teach well, or is it that they didn't finish the question, right? So this is basically what data analysis is all about, right? We are entering data analysis now. So data analysis is basically getting insights from your data that will help you to make decisions, right? It will help you to make decisions. So now what I did here is an insight. I've done analysis already, right? I've gotten an insight of my student grade. Oh, my student grade, the list is 9 is 10, right? Okay, I can just come here and change it. I say, let me get the maximum. Oh, the maximum is 69. Wow. You can be like, wow. So out of all my students, so the highest someone can score is 69 over 100. That's actually something to be worried about, right? So it has given you an insight. So that insight will now fuel your decision making. So you can now say, oh, maybe I need to retouch that topic, or you need to post a tutorial for them, or you need to do something to help them understand the concept so they can score higher, right? So that is exactly what data analysis is all about, and that is what we are going to be doing. And from moving forward from here. So these are aggregation functions. So you just have to know them. There are a lot of them actually. If you always check your dir np, right, you are going to see a lot of things. So you can scroll down. You can you can just explore on your own. There are a lot of things here you can explore on your own. So if we check, you are going to see. Let's go to check for mean. All right, you can see mean, right? You can see max. Where is max? You can see max. You can see mean, right? You can see median, right? There are a lot of them here. So basically, you can just explore that on your own, right? So let's just move on. So now this is mean and max, right? So you can also get standard deviation. So standard deviation is basically telling you how much your data, like the spread of your data. It's telling you the spread of your data basically. And standard deviation is always read together with your mean. So you can't just interpret your mean in isolation. So whenever you are getting the mean of something, it's always good that you get the standard deviation too. So you use both of them to understand your data. So let's assume I get the mean of my data here. The mean is what? 39.5. So this 39.5 just tell me that, oh, the average value is 39.5. Okay, makes sense. So you can as well get the standard deviation to np dot standard deviation. So this is the syntax for standard deviation, STD. Right. So know all these things, right? As you're working, you'll be using all these functions. So just know them. It's not, sometimes you might forget and you might say, is it standard deviation in full? Or so sometimes it's very okay, but just understand the function you need to use. You can always just browse Google and just look up something in your textbook or whatever, but just understand how to use all these functions. So np dot standard deviation, right? We'll just put your array here. You can come here and say array std. That's great. So and say print the standard deviation of array is array std. Okay, so this is it here, right? 17.3181, blah blah blah. So you can see how it is long, like it's actually So now let me just quickly show you how you can reduce this value. So sometimes you might get a long value, like plenty decimal values, right? So in Python, and I'm introducing to another function again in Python, is what we call round function. round function. So in this class, I've introduced two new functions, len and round. So what round function does is that it rounds up um your decimals, right? So if I come here and say array standard, so it takes in this value, right, as an argument, and the second argument is the number of decimal places you want. So let's say I just want two values here, 3 and 1. I'll say 2. I hope I got this correct. All right. So if I just want to, I'll indicate to say if I run this, right, and still I can just come here and say array standard props. So I can come here and put this here. As you can see, it has rounded it to two decimal place. So instead of having a long list or a long value of decimals, like that will just spread everywhere, you can just round it up by using the round function. So I've introduced another function again, as you can see. So there are a lot of useful functions in Python, like a lot of useful functions. So if you can think of something to do in Python, just know that there's a function for that, right? Because right now I saw that list and I was like, I need to round this up. And I remember that there's round function. So I now use the round function. So it's very good to read wide, so you'll be able to be more versatile and flexible in Python. So you can see that it actually approximated it. So it was 318. So it approximated it to 2. So if I change this to 1, if I come here and change it to 1, it's going to make just one value, right? If I change it to, let's say, 4 decimal place, it's going to give me 4 values after the decimal. So that is actually a very good way to approximate your numbers. So yeah, I was talking about standard deviation. So now the standard deviation of our array is 17.32, right? So what does 17.32 mean is how the data is spread from the mean. So remember we said our mean is let me come here, let me copy this. The mean over. So remember I said the mean of our array is 39.5, right? So now we now want to interpret it in light of the standard deviation. So what this standard deviation is telling us that, okay, from this mean now, the spread in the left side and in the right side is 17.32. So to get a better understanding of the kind of grades that we have, we are going to just say something like this: upper bound. This is just to explain it for you. This is not actually a standard stuff, just to explain what standard deviation mean. All right, so you can see upper bound 39.5 minus 17.232, and lower bound 39.5 plus 17.32, right? So you can come here and say print the range the values of the grade of the students for between, let's see, okay, this is supposed to be lower bound, and this is supposed to be upper
Yeah, good evening, everybody. I think his network is bad, so he'll be coming back in the next few minutes, in the next few seconds. So let's wait for him. And while we are waiting, please, I want to encourage us. There are some of you who come to class, and within 10 minutes you are out. Please, I will encourage you to stay longer, because if the BOT is crawling through your names, and maybe you just come to the class and you leave, it will not get your name. The BOT crossed 3 times throughout the 2 hours class. So, and the time it cross, I don't usually say it. It will can cross at any time, can cross 30 minutes after the class have started, 45 minutes after the class have started, maybe 10 minutes before the class ends. So it's good your name, you are there, so that at least the BOT crosses once, so that it will capture your name for your attendance. Your attendance is very important. Thank you. He's back now.
All right, thank you, Mr. David. I'm really sorry about that. My network was just acting up. I'm glad I'm back. All right, so let's just continue. All right, so now just have to print the lower bound and the upper bound, right? Where is the uh, okay? Where exactly? Okay, yeah. All right, great. So all right, so now we'll see that the grades of the student fall between 22.18 and what? 56.82. So now this actually helps you interpret the data better, right? Although it is not entirely accurate, there's an error to it because remember when we talked about the mean and max, we had a 10, we had someone that got 10, and we also had someone that got 69. But this would give you an idea better that this is where most of these grades of the student fall into between 22.8 and 56.82. So this is actually how you use your standard deviation and your mean to interpret to get the center of your data, or where most of the values fall in. So that is it for mean and standard deviation. I just wanted to explain that, right? So now we've talked about a lot of stuff already. We've talked about the aggregation. We've talked about the mean. We've talked about some. We've talked about some extra things like how to get the length of a list or an array. We've talked about the round function, right? Very very useful. And now we've talked about the standard deviation too, right? So we'll be moving on. So there are a lot of other functions you can use to perform either a statistical operation or an aggregation operation. So we also have median. Right. So depending on what you want to do, your question, you just find a particular function in NumPy that can do that. So we have median. Median will tell you the mean and the middle number of your array. So these are statistical operation. If you take statistics before, you remember. Please, Francisca, check your network. I believe others can still hear me. Right. So, if you've taken statistics before, you remember, you know what we know that we have what we call measure of central tendency, and we also have measure of dispersion. Right. So, these are actually ways to summarize your data, to understand your data. So, now let me just quickly brush over that. Um, Remember, when we're discussing foundations of data science in week one, I said something about data science. I said data science is a combination of different fields. It's a combination of computer science. That is where we have programming, Python that we'll be doing since. Combination of statistics, right? Now, this statistics is what we are doing now, that we are trying to use statistics to understand our data, right? So it's also a combination of mathematics. We've been doing mathematical operations, right? So at least the basic one for now. We will advance to we will move as we are more advancing. We'll be looking at more concepts in mathematics. Although not deep, you don't need to. Don't worry. Don't worry about that. It's something that you understand. So these are things that makes up data science, right? So you see, we've been taken from different places. So let me just quickly round up with this, so we can enter pandas, right? Um, so what is it? All right, so I just want to quickly talk about the measure of central tendency. So measures of central tendency. So these basically are values that tells us the center of our data, the center point of our data, and they are the mean, mean, median, and what mode. So these are the three things that tells you the center location of your data. So if you want to understand the center point of your data, you use this either of um these three aggregation, right? So for measures of dispersion or spread. So we have two basically. We have standard deviation and we have variance. So these are the two ways to measure how your data is spread across the mean, right? So it's basically used to understand you. So these are the concepts that you will be using frequently in understanding your data. So in data exploration, remember when we're talking about the life cycles of data science, talk about a stage where you do EDA, exploratory data analysis. These are some of the techniques to be using in that particular stage, right? So we'll be talking about that. And next week, when we are rounding up with pandas, we are going to actually illustrate how to use these libraries to analyze a real data set, like a data set that I'm going to be bringing a data set that we're going to work on. So you see how data analysis is. And the assignment that will follow is you too working on this data set. So let's just leave that till then. Right, so it's actually going to get interesting from here. So we are entering the real data analysis now, right? We've talked about all the things we need to talk about in Python, right? So at least to get you started. All right, let's just move on so we can quickly enter Pandas because of time. All right, so we are going to talk about some other things in NumPy, random number generation, right? So we have random number generation. So NumPy actually has a particular module that help you to generate random numbers. So now, remember we talked about NP, like to create an array. We can use creating an array. We can use NP dot array, where you're going to have to pass in your array into the as an argument. You can use NP dot can someone give me options, please? Like, let me see if you can still remember. Let me what are the different ways we can create arrays using NumPy? Like, let me get feedback, please, on the group chat. I'm waiting for you. NP dot zeros, NP dot arrange. Exactly. NP dot ones, perfect. Right. There's one that nobody has said yet. NP, no, we don't use concatenate to create array. Exactly, NP dot linspace, that's what I'm looking for. So we can just list them here, NP dot ones, NP dot zeros, NP dot linspace, and we have NP dot arrange. Right, so these are the ones that you know how to create arrays in NumPy, right? So now there's one, I don't know if there's E in zero. All right. So there's actually what we call generating random numbers. Random numbers in NumPy. Right. So NumPy provides using np dot random. So NumPy provides a module called np.random. So this np.random is not a function, is a module. Right? Remember I told you that NumPy is a library. So a library is actually a collection of functions and collection of modules. So np.random now has its own functions. It has its own function. So I'm going to just show you what I mean by that. If I come here and say dir, this dir is a very, very useful function. So I believe you also be using it too. I say print dir np. I'm going to get all this, right? All these things. I'm going to get all these, like all the things you can do directly with NumPy. But now there's a particular module called random. If I say random np.random, I'm going to get another list of things that you can do, right? Another list of things you can do. So now this random is a library in NumPy, sorry, a module under NumPy. It's just see it like a library inside NumPy, but you don't call it a library, call it a module. So NumPy is the bigger one. You now have another one under it, which is random. So the random now has its own set of functions, right? So that's what we're going to be using to generate random numbers. I'm just going to quickly talk about that. So in this random, we have different things. As you can see, we have Poisson, we have a lot of things. So what I'm going to talk about here is rand, rand int, and rand n. Rand n. So these are actually ways to create random values in using NumPy. So I'm going to quickly show you something. Let me comment this out. I'm going to quickly show you something. Whenever you want to use a function in Jupyter Notebook and you've forgotten what that function does or how to use that function, there's a shortcut you can use to get to see the information pertaining that function. So if I want to use, let's just look for one, array, np.array, and I've forgotten how to use it, maybe I've forgotten what to put here, I can just say np.array. I will not put the brackets, I will now put question mark. Like I will put question mark. So this is a shortcut to ask Python, okay, what does this particular function do? It's like this question mark is like asking the question. So if I run it, this is what I'm going to get. I'm going to get something like this, right? Is getting a documentation of that particular function. So it says array, right? So these are the parameters: object, d type, right, and a lot of other things that you will not likely use. So this is what it does. It creates an array, right? It now explains the parameter, each parameter. So an array, any like exposing the array, blah blah blah. You just read through. So in case that you want to understand what this d type is, you can just read through it. So this basically shows you how to use this particular function. You can use it for any function in Python, anything, right? So now you can scroll down. You even see examples, right? So you see, it even gives you additional information. Like these are other things you can do, right? It give you examples too. So it gives you example of how to use it. np.array, right? So basically you have everything with like Python is literally giving you a lecture on each function. So you can come here and say, okay, I don't understand linspace. Let me check linspace. So I'll do np.linspace with question mark and I'll run it. As you can see, it gives me this particular documentation, right? So this is np.linspace. This is the parameter you put: start, stop, the number of values. So these are other things that you can put, but you will not really use them. So these are the ones we've been using since these three parameters. All right, so see everything that has to do with it to explain each of these parameters, right? And then tell you what it returns, and also gives you example too. So it's just very interesting. Like I believe this is going to help you a lot. So that is it for if probably you are coding and you forgot how a particular function work. You can quickly just use that shortcut to get you to understand how to use it. So now for np.random, you can use it to create random values. Like let's say you say np.random. If I say np.random and I put question mark, it's going to give me, you see exactly what it's giving me now. It said this is a module. This is a module. This is not a function. Okay, when I put np.array, right? So where exactly? Okay, they didn't really specify it here, but this is a function. Let's check under one, len space. So everything is actually not the same thing, right? So this one indicates here array function, right? So this is a function. So the way it is explained for different, is different for different functions. The explanation is different from different functions. So don't expect the same format for everything, right? So for random, someone can hear anything. Please, can everyone still hear me? Can everyone still hear me?
Yes, can hear you.
All right, perfect. So now if you use the np.random, you're going to get this. So np.random is a module, right? So it will explain everything for you, what it does basically, and some of the things there, right? So now to get the functions in np.random, you have to put another dot, np.random dot random. Like this is actually confusing, but this is the function in this random module. So we can say np.random.rand is a function too. np.random.rand int is a function too. So let's say we want to understand what this function does. We'll just put question mark. All right. So it will tell you exactly what it does. Okay, this returns random integer from low, right, inclusive to high. Right. Basically, that is just it. And you read through and you see examples. You can even see examples here. So random.randint to size 10, right? So you can basically see how it works here. So you can just scroll through and just read it basically. So like that is just it for that. So to create random values, you can use the functions in this random module, right? You can use functions in the random module. So you can say np.random.theory is going to randomly okay, let me just get this. So if you say np.random.rand in this particular function, anything you put in as an argument here is like the maximum number that the random is going to use in generating the random value. So what this basically means is that any random value it's going to be generating will not pass 7. So if I continue running this, if I continue running it, you see it will be giving me random numbers 4, 0, 0, 1, 5, 2, 2, 3, 5, 5, 0. So basically this is just to generate a random integer. That is what rand int mean, right? Rand int. So this 7 mean it should not pass 7. So you've not seen anything that is higher than 7 yet. So if I put 100, you see that it's giving me bigger values, but it's not past 100, right? So that is what basically rand int do. For rand, so rand basically is going to give you an array from 100 arrays between zeros and 1, right? So between zeros and 1. So we're going to have generate a list 100 values, 100 random values between 0 and 1. All right, let me remove this. So that's what it does. If I say 10, it's going to generate 10. Remember linspace, right? Linspace is different from this one. No? Linspace does not generate random values. Linspace generates uniformly distributed values. Why random generates random value, right? So it generates now 10 values between 0 and 1. So you can say everything is 0 point something, 0 point something, 0 point something. So there's nothing here that is above 1. Everything is between 0 and 1. So there are situations where you will need to have a list of values between zeros and one. That's what random module does. So you have rand n. This is for normal distribution. You have rand int. So basically, you can just explore it on your own. You can even specify the size. You can even specify, I think, size equal to 2 and 5. I don't know if I'm getting this correct. Think shape. Think it should be shape. So you see, in this situation now, I've forgotten exactly the argument that's supposed to be here. So you can just quickly come here and do rand. So this is just to give you an example of what this does. So I'm come here and say, why exactly is this? Like this. So all right. So um random dot rand, right? So you'd get something similar, right? So I don't know if I'm missing something, but just for the sake of time, let's just go through. So you just understand how to generate random values now. We'll look at that later on because of time, because we still need to enter pandas for today. So basically, that is it for generating random numbers, right? So we have random.rand 5, we have random.rand n for normal distribution. We have, so these are just introductory concepts. So don't if you don't understand some of these things I'm saying, just be patient with yourself. You will get to understand that with progress. So we're going to be entering pandas for today. One thing about this course, data science course, is that we don't really have enough time. That is just the truth. Like, a lot of things to talk about. Like, I wish I have enough time to talk about a lot of other things, give more examples and everything, but we don't really have time. So that is why I'm always emphasizing on you reading and you looking on at extra other examples from external sources and the textbook that we recommended, right? So at least we'll move very, very fast. So for today, we'll be introducing pandas, right? We're using pandas for data analysis. Now we've talked about NumPy. We've talked about what NumPy is and what NumPy can do, right? Now we'll be talking about pandas. So for pandas now, these are the things you're expected to know at the end of this class, right? So at the end of the class, you understand what pandas is and the data structures, know how to perform basic operations on series and data frames, and understand the different data manipulation and aggregation techniques in pandas. So we're not going to be finishing pandas today. We'll just do the introduction today, and next week we're going to wrap up with pandas. So for today, we're just going to be looking at the data structures in pandas. So where exactly is pandas, right? So pandas is an open source Python library for providing high performance, easy to use structures and data analysis tools. So this is just an introduction, people that developed it, right? So this is another key information you need to know. Pandas is built on top of NumPy package. Like, remember I told you that NumPy is the foundation of most of the other data science library. So you have to know that NumPy is like the foundation for every other thing. That's why we introduced it first. So Pandas is built on top of NumPy package, and it has a separate or a unique data type called a data frame. You know, I introduced an array when we were talking about NumPy. So array is for NumPy. Now, data frame is for pandas. Or actually, there are two data structures or data types in pandas, but the main one is what we call a data frame, right? So data frames, we'll talk about data frames later, but this is basically what pandas is. So pandas actually is an abbreviation for panel data. Pandas, panel data. So that is just an extra information. So we have specific data structures for pandas used in pandas, right? So in Pandas at the very basic level. And I told you that Pandas is built on top of NumPy, right? So people that created Pandas on after they've created NumPy. So because of the reason why they're using NumPy is because of how fast NumPy is. Remember, I told you NumPy is very fast. It is efficient. It uses computer memory very well. So the way it is built, the way NumPy is built, it makes your work very fast. So every other library that is being built would use NumPy as the basis for their data structures. So at the core of Pandas, we have what we have the array. So the pandas object is actually built on top of NumPy array. So they just modified it a little bit and added some things to give it the uniqueness that you see in pandas. So at the very basic level, pandas object can be thought of an enhanced version of NumPy structured arrays. So that's why you need to understand NumPy arrays well, because every other thing is going to be built on it, right? So basically, this is just a summary of the data structures. And yeah, what we are going to be working on is data frame and sometimes series. I'll introduce that in a few seconds now, right? So Pandas provide a host of useful tools, methods, and functionalities on top of the basic data structures. So there are a lot of functionalities, the same way we have been able to work with NumPy, and there are a lot of functionalities, functions, methods, aggregation techniques, random generation, and all those things we talked about. So Pandas has a lot of them. Like you can't even learn everything like within the span of time that we're going to be having this program, but you just have to understand this. So now we have two data structures in Pandas. We have the Pandas series, right? We have the Pandas series. So this Pandas series is one of the core structures in Pandas. Remember, I said data frame. We'll talk about data frame later, but this series is one of the core data structures in Pandas. It is fundamental in data manipulation. And the key thing to note here is that it represents a one-dimensional indexed array capable of holding any data type. Right, so this is something you need to note. It represents a one-dimensional. So Pandas series is one-dimensional. One-dimensional meaning it has just rows. It has just rows. It does not have, although in this case, you say it has one column and several rows, right? So we're going to see that as we move on. So, and it is indexed. This also is very important. It is indexed, right? And it's capable of holding any data type, right? From integers to strings to float and also other things, right? So, I'm going to look at an example, right? So how do we create a series? How do we create a series? You know, remember creating an array, we can use np.array. So how do we create a series? For pandas, let's just open here and say import. Remember, you have to import pandas as PD. Now, the alias used in pandas is called PD, right? So this is the convention. Anywhere you see PD, just know it's pandas, right? So the same thing, the same idea for NumPy that we're bringing in here. So import pandas as PD. So to create a series in pandas, what we use is pd.series, pd.series, right? So sorry, pd.series, it follows by brackets, and then this, it will take in, what it takes in is usually an array. So you can take an array of, let's say, a list, Python list. You can take a Python list or NumPy array, any kind of list. So let's say I use, or let me even create an array separately. Oh, yeah, I think I do have an array already that I created. That is array for the students course. So I can just come here and put the array, right? So, all right. So now this is basically how to create a series, as simple as this, like pd.series. And something you need to notice that the S is usually big in capital letter. Like normally the ones we've been doing, they are usually in small letter like array and the rest. But this one, the S is in capital letter. So note that because sometimes you might put small letter and it will give you an error, right? So pd.series followed by the array or the list that you want to convert to series. So if you run this, you're going to get something like this. This is basically what you're going to be getting. These are this first row, this first thing here that you're seeing is not a column. This 0, 1, 2, 3, 4, 5, 6, 7, 8. This is not a column. This is an index. Remember, I told you something about index here. That Pandas Series is indexed array. So whenever you create an array, it will automatically create an index for each of the elements in that array. So remember, this is the array we created, student scores. So we have 10. Let me just quickly create another array. This one is not, what I want. So you can come and say np.len space, let's say between 5 and 100 and 20. Right, so I'll just say array. So now I've gotten this new series. So you can see this is the 5, 10, 15. This is actually my array, right? And now this one is the index. So the index is always printed out with the array. Remember when we were working with NumPy array, we don't usually see the index. The index is hidden, right? So we just know that each of the elements. But in Pandas, the Pandas series, it automatically prints the index of each of the value in the array. So this is basically what a series is. It's a one dimension. So this is the column here. This is just the only column we have here, right? So this is the one dimensional series that we're going to be working with in Pandas. So we can just assign this to variable, right? And we can check the same way we can check for attributes using in NumPy array. We can also check for the attribute of a series too. So we can say what's the shape of the series, right? It will give us 20. You see, it's one dimensional. So it just has 20 rows. That is 20 rows and no columns, right? So if you say size, the size is what, 20. If we say ending one dimensional series. So a series is always one dimensional, like always one dimensional. So there's basically no need to check for the dimension here. So you can also say D type, right? So the data type for this particular series is a float, right? It is a float. You can actually, the same way for array, you can actually also specify the data type here to whatever it is that you want. You can say int in 64, right? So you see to change to int 64. So that is what a series is in Pandas. So this is how to create a series. pd.series array. You can see that it is different. So you can come here and say print series. That's why it's different from an array. An array is, let me print this array. Print array. You can see how an array is. An array is just there, right? Just a list of numbers. But a series is like it is arranged vertically with index by the side. So just note that that is what a series is, right? So as you can see here, a series is in Pandas is essentially a single column in a data frame. So once we talk about data frame, you understand what a series is more, right? And all right, so am I moving fast? Am I moving too fast? Is my pace okay? Let me get your feedbacks in the comment section, please. all right. Okay. But hope we understand what a series is. What a series is. So we've just introduced. Let me just go back to what we've talked about. So far, we've introduced pandas, and I said pandas is basically for data analysis and data manipulation in Python, right? So there is nothing much to talk about there. We talked about the data structures in pandas. We talked about two data structures, series and data frame. That's just all you have to know about the data structures, series and data frame. We are going to be working with these two data frames, nothing else. Right? Everything we are going to be doing in pandas is going to be on this data frame. The same way everything we did on NumPy in NumPy was attributed or is based on the array data structure. So just understand that. So now we've talked about series, and we talked about how to create a series, right? So basically, we know how to create a series in pandas, right? So let's just go over the characteristics of the series. So now a series has an homogeneous data. What do we mean by this? Now each series can only be a single data type. Like the same that is to tell you that this thing is similar to an array. So when I told you that pandas is built on top of NumPy, this is exactly the what I mean by that. So everything characteristics of an array is reflected in this pandas data structure or data type. So a particular series can only contain one data type. It can either be float, or it can either be an integer, or it can be an object, right? So for instance, let me just give you an example now. Let's say we create this particular uh okay. Well, let's just say we create an array or a list array. Come here and say np dot array, and we say 3, 4, 5, 6, and we put a string there, and we say pandas, right? And we say 3. So what NumPy does here is that it sees that there are two different kinds of data type in this list. So it will look for a way to force everything to be of the same data type, because it can't have two different data types in this list. So it will now convert everything to a string. It will convert everything to a string. So that is exactly the same thing that happens in a PD series. So if I come here now and create a list and say, just bring in this list here and put it here, what is going to happen is that if I pass this thing, I'm going to get this, because of this string that is here. This entire series cannot be a float again, right? Because there's no way it can convert these pandas to a float. So it will now convert all these numbers to a string instead, and it will now assign the data type object to it. So if you come here, you see the list of values, the value list, and you can see the data type. The data type is an object, right? So what this object means is that there are different kinds of data type in this particular list that we passed in. So it now converted everything to a string. So all this data type we have here, they're basically strings. So you just classify it as object. So just note that. So it's basically the same thing as a NumPy array. So they were on the characteristics. So it has homogeneous data. You need to know that. It has flexible indexing, right? So I told you that a NumPy array, a series, a Pandas series always has an index alongside the values, right? It has an index always. So whenever we don't specify the index, maybe when we are creating, let me for this. So whenever we are creating a Pandas series and we not specify any index, it will automatically use the 0, 1, 2, 3, 4 index for it. But we can actually also come here and specify the index, right? You can add additional argument and say index is equal to, you now start typing it out. So we have how many values here? We have 1, 2, 3, 4, 5, 6. So we're now going to type out the index we want. So we can say A, B, C, D, E, and F, right? So, okay, I didn't close this. So if we run this, what exactly is the problem here? How many values do we have here? 1, 2, 3, 4, 5, 6. We have 1, 2, 3, 4. Okay. Okay, so now we have this. The difference between this series now and the former one we did is that this index is now explicitly stated. We are explicitly stating the index here. So if we now print out the series and we come here and say series, we're going to get the index that we state. You see, instead of having 0, 1, 2, 3, 4, 5, we're now having this index that we stated here. So that is basically what this flexible index means. You can actually change the index of your data, right? So now we also talk about alignment via index. The same way you can, this is basically operations you can perform on index. So the same way you can perform operations, right? Same way you can perform operations on NumPy array, you can also perform operations on series. So you can actually slice series. You can come here and say series dot give me the 0th element. So it will give me 3 here. So this is just a warning that Pandas is giving us, right? So I can come here and say, give me the first element to give me 4. So give me from first element to third element to give me 4 and 5, right? With their index, with their corresponding index. So you can see it. So I can perform slicing on series, Pandas series, right? So the same thing for NumPy. So if you understood NumPy, understanding other libraries would not be a problem because they are built on NumPy. So now we'll look at other things. So as you can see, you can actually slice element. So now remember I used the normal index, maybe 0, 1, 2, 3. It will still work, right? So even if I specify the index here manually, and I come here and now say index 0, it will still work because inside the memory, all these things are still indexed with 0, 1, 2, 3, 4, 5, right? But we can actually come here and specify this index that we've defined here and say B, right? It will give me 4. If I come and I say C, to give me 5, right? Do you understand? So if I come and say C to F, to give me everything from C to F. Do you understand? Like this is basically a very flexible way of working with Pandas series. So the same thing for NumPy as NumPy array, right? So we can slice that I've just described now. We can actually index and we can also slice series. We can also perform arithmetic operations on Pandas series. So we can add 2 series together. We can divide series. You can multiply, right? So if I come here and I create 2 series, I create another Pandas series, right? I come here and I create, so but just make sure that the values are numeric because there's no way you can perform that operation on this kind of data. So I say this one is series 1. I come here and I say this is series 2. Series 2. So I'll just remove this index for now. So come here and then come here and quickly do this. So I will change this 6 to 1 9 8 7 5, right? So I've created 2 series, right? And I want to perform an operation. I want to subtract this series 1 from series 2. I can quickly do that by just using your normal arithmetic operation. Series 1 plus series 2 to give me a new series with the results. as you can see, the same thing for NumPy, right? So you can do addition, you can do um, subtraction, right, to give you the value. You can do multiplication to give you the value. You can do division to also give you the value, right? So this is just straightforward, like very, very straightforward. And make sure that when you are doing this, you have equal although the in NumPy arrays, we see that when we perform operations like this with unequal values, it's going to give us an error. But in pandas actually kind of remove that error that NumPy would throw at you. So what it just does is that for that particular value that don't have a corresponding value, is going to just result to what we call NaN. This NaN means not a number, right? Instead of throwing an error to just give you NaN, basically. So you can actually um, have something like this. So the ones that don't have corresponding number will result to this NaN. So the ones that have corresponding number would have the operations performed on them. So Pandas series actually is robust. It doesn't give you error when you are performing operation on two series that are not the same size of the same size. So just note that that is one difference from array. So that is the kind of operation you can perform and using Pandas series. So we can also do handling missing data. So for this one, we are going to actually talk about it when we are working with a data set particularly, right? So, but just know that you can actually handle missing data in series. So in sometimes you might have a data set that have missing values. So there are ways to tackle that. We'll talk about that. So let's just pause on this for now. All right. So this is the function we use for that. Right. So let's just move on. Or let me just quickly talk about this. Like just quickly talk about this. Let me just try to create a value for that. So now I'm going to assign this to a new series theory. So this series theory now has missing values, right? So these missing values, I mean, these are the missing. Remove one from here. So these are the missing values here. This NaN mean missing. Something is missing, right? So whenever you're working with the data set, you might encounter something like this. Like let's say you are doing survey data, like you are doing survey and you went out to the field and you collected the input of different respondents. So maybe a particular respondent filled in their age, they filled in their occupation, but they didn't fill in their state or they didn't fill in something else. So there will be no value there. So when you finally import that data into Pandas to work with, Pandas will represent that missing values with this NaN, not a number. So this NaN is actually a problem for data analysis. You can't work with NaN, so you have to do something about it. Remember when I talked about the stages of data science, I talked about data cleaning. So this is actually a step. Yeah, this is actually a step in data cleaning, handling missing data. So it is very common problem we face in data analysis, right? I just want to illustrate how you can handle that quickly in series. So if you have something like this series that has a missing data, you can actually use this particular function drop NA. What drop NA will do is that it's going to drop the missing value. It's going to remove it from the data frame, right? So if you use the drop NA, it's going to just remove it. Like, okay, we don't know what to do with this missing value. Let's just remove it. So this particular function, drop NA, is going to remove it. But there's something you need to note. If I come here and print series, you will see that series theory rather. You see that we still have our NaN there, right? We did this drop, but it's still here. The reason is that we did not tell Pandas that we should make it permanent, right? So there's a particular argument we use in Pandas to make our to make the action we are taking permanent on our data sets. So you need to be very careful with the way you use it. So that is actually called in place. In place. So in place is the argument that you use. So you usually use equal to true. So in place equal to true mean that, okay, this drop that I'm doing, dropping the missing value now, make it to apply to my original series data. So if I come here and I do this in place equal to true, and I come and print series 3, I'm going to have nothing here. Like, it has made it permanent, right? So it has actually dropped the missing data from my original data set. So if I don't include this in place tree, to just drop it without really making the action permanent. So that is just one thing you just have to know, right? So there's another way to work with missing data. So is using .fill NA. So fill NA basically mean you fill that missing data with a particular value. So I can come here and put a value there. If I say fill the missing data with 4, it will fill it with 4. I use it as fill it with 4. If I say fill the missing data with 7, it will fill it with 7. Can you see? So that is just the two ways you can handle missing data. I just wanted to say that, but we're going to talk about it more when we do data, when we are working with an actual data. So this is just something else you need to know. Vectorized operations. So pandas, I've told you about vectorized operations in NumPy. So pandas support vectorized operations and automatic data alignment, right? So it's just like the broadcasting we talked about then, right? So pandas can also do the same thing. Pandas series can also. So almost all things you can do with NumPy, you can do with Pandas series, right? So now this conversion is actually something you can also note. You can actually convert a series to a list or convert a series to a dictionary. So in some cases, you might want to convert your series to a list. So a Python list, you have your series 1. So you want to convert it to list. You now say to list is a function to use. So I can say series to list. So what this will do is that, let me print series to dict, right? I'll say series 1 to dict. So these are important methods to know, to list and to dict. So that will convert where is it? Okay, what is the to dict? There's an underscore here. So it's very common to have errors in your Python. So whenever you see errors, don't panic at all. Like, don't even, it does not mean you don't know what you're doing, right? It's just Python is not understanding what you are saying at that point. So you need to check the error to know what exactly the problem is, right? So now I was given an error to correct my mistake here. So nobody's actually a perfect programmer. So you always get errors. So sometimes you even see people complain about their error, their bug, their whatever. So it's a very normal thing in programming. So don't panic whenever you see that, right? So just focus on how to resolve the error. So this is two things. We want to convert our series to list and a series to dictionary. So if I come here and I print the series to list, and I come here and I print series to dict, you see that the series has been converted to a list, and it was also converted to what? A dictionary. So this dictionary now, let me put it in a way that will be better. So this dictionary, you see that it has the index as the key and the value as the value, right, as the value of the series. So index as the key and the value here, index. So that basically that is just how it's going to represent it. So these are the things you can do with Pandas series. Like there are a lot of stuff. So these are the basic things you can do with Pandas series, right? So now we'll move to Pandas data frame. Now this is the main data structure we'll be working with in Pandas. So what the series is just another data frame. You might not necessarily be working with it directly, but you'll be using it indirectly. But the main data type you'll be using in Pandas is a data frame. Pandas data frame. So what is Pandas data frame? A Pandas data frame is a two-dimensional. Remember, series is what one dimensional. Pandas is what data frame is what two dimensional. Size mutable, potentially heterogeneous. So if I ask you for the difference between a series and a data frame, you can now tell me that series is one dimensional, data frame is two dimensional, series is homogeneous, data frame can be heterogeneous, right? So if you see your Excel table or your Excel sheet, you see rows and columns, right? So that is what Pandas data frame is trying to represent or trying to replicate here. So data frame allow you to store and manipulate data with integrated indexing for both rows and column, making data manipulation easy and intuitive. So now these are the characteristics of data frame. It has a labeled axis, right? So both rows and columns are labeled. It has an heterogeneous data, right? So what this means is that each column has, for the data frame, each column can have different data types. So column one will have column one can be float, column two can be string, column three can be integer, column four can be another thing. So that's just basically what we mean by heterogeneous data. Unlike the series that it just has one column and that column or row and that column has just one data type. So size mutability. So data frame allows you to modify its size. You can add rows, you can delete. So there are a lot of things you'll be able to do with data frame. Like this is the main thing we'll be working with while doing analysis in Python with using Pandas data frame. Right. So efficiency. So as I said, Pandas is built on top of NumPy, making operations on them extremely efficient, particularly for large data sets. So trust me, Pandas is going to be very interesting. Like, very, very interesting. Let's just move on. So now, how do we create a data frame? We've already talked about how to create a series, right? So how do we create a data frame? We can create a data frame using a dictionary. Remember the dictionary data type we talked about in Python, creating a data frame. So a data frame is a collection of rows and columns. So a way to create a data frame is by using dictionaries, right? But the thing is that you won't be creating data frames. You will mostly not be creating data frames in Pandas. You'd be importing your data from an external source. And this one, we're going to discuss it next week, right? So I just want to give you an idea of what the data frame is. So to create a data frame, you use what we call pd.data frame. Now note the cases. So D is what in capital letter, F is what in capital letter. Python is case sensitive. So if you don't put it like this, it's going to give you an error, right? So this is it. So you see, if I change this, right, it's telling me modules, Pandas has no attribute data frame because this F is in small letter. So make sure that it's in capital letter. So this is what we use to create, and the series to make sure S for series is in capital letter. So this is what we use to create our data frame, pd.data frame, right? So now what do we pass into the function? We pass a dictionary, right? We pass a dictionary. So I can just come here and say my dict. Currently, we don't have any dictionary, so we're going to create one. So I'll come here and create a dictionary. I'll say let me just copy the one that we already have because of time. So I'll just come and copy this, copy it here. Hope you remember a dictionary data type that we talked about when we started with Python. So we have the key here, name, and we have the value. Now, just take a look at something. Now, the value of this key is a list. Yes, we can actually have a list to be the value of a key in a dictionary. So we can have different keys with the list as the values. So we've created the data a dictionary here. So we'll just come here and change it to data. So once we put in the data to this data frame function, it will automatically convert this dictionary to a data frame. So this is what we are going to see. If we run it, this is what we are going to see. Have you seen how formatted it? This is unlike what we've been seeing in Python. So they really took that time to make sure that it is easy to read. So this is the index. Yeah, this is the row. It will automatically always give you the index as we talked about in series. And this is the column. So this is the column. This is like an Excel worksheet. So row and what column. So now, as you can see, it converted the keys here to the columns, and it converted the list here to the values, right? And it automatically also added indexing. So we can do the same thing we did for series. We can specify our index here. You can see index is equal to A, B, C, or you can actually say first row, second row, and third row. So if I run this, what exactly is okay? I didn't close it. So if I run this is what I'm going to get. I've changed the index now. So you can actually manually change your index. So this is for when you are creating data frame, right? But when you're importing your data, there are the different ways to do that. So I'm going to as when we are working with the data in the next class. So, but basically, this is how a data frame is, right? So if I add another value here, but let's say I add state, I come here and add state, right? And I say state, first person is from, let's say, Enugu, second person is from Ogun, third person is from Lagos, right? So now make sure that the number of values here correspond to the numbers that you have in the previous keys. So if I run this, all right. So what is the issue now? Python. All right. So as you can see, it has automatically added state now as a column to my data frame, right? So this is basically how a data frame would look like. So this is a very small data frame. In reality, you have a long list of columns like 15, 10, 20, and you have plenty rows like 100 rows, 200 rows. So you imagine how it would be. It is going to cover everything here. And sometimes you even need to be scrolling, right? So this is basically what a data frame is. Now, a data frame has several attributes, right? The same way we have attributes for other data structures. So we can come here and say, we can assign this data frame to my data frame. You can use df to a variable. I can come here and say df dot shape, right? What's the shape here? 3 and 4. Remember from NumPy, 3 means what? 3 rows, 4 means 4 columns. So the data frame has 3 rows and 4 columns. So bringing the understanding of NumPy now. So we can say ndim, number of dimension is what? 2. So this is a 2-dimensional data frame. So a data frame is always 2-dimensional. It's not possible to have a 3-dimensional data frame. So don't worry about working with 3-dimensional data frames. I know in the one we did in NumPy is almost confusing, right? So we're not going to work with 3-dimensional data frame. We're just 2-dimensional. So the ndim is 2, and we can see data type. When we use data type, it's going to show us the data type for each column. So we're going to get something like what exactly is the okay? So okay, this is not the correct function for that. So now let me just quickly talk about the columns. So for each column, we can just write columns, and then it will show us the columns that we have for that particular data frame. So it will return the column. So we have name, we have age, we have occupation, we have state, right? So these are the columns we have. So there are a lot of functions, there are a lot of attributes that we have. So we'll just go through them. We have df shape, we have df columns, which I've talked about. We have df index. So we can actually just come here and say df index. What's the index of the data frame? So you can see to bring a list of the index we have: first row, second row, third row, right? So we also have dfd types. I don't know why that wasn't working the other time, but let me try again. Sometimes Python can be very annoying. Okay, great, it's working now. Okay, I didn't put S. Okay. So you can see how it is easy to make mistake. I love how this is happening, right? So you see exactly how the realistic view of working in Python or in Pandas. So sometimes you can make a very silly mistake as just not including S here. And you just be saying, what's the problem now? You'll be asking question, you screenshot and send to the group chat. See, my code is not running. Why? The problem is just to add an S here, right? So you just run it and it will give you this. So it's going to give you the data type for each particular column. So for name is an object because it's a string. For age is an integer, right? For occupation is an object. For state is an object, right? So basically, this is just summary of data frame in Pandas. We are going to be taking our time from next class to talk about how to manipulate a data um, frame, right? That is going to be the main focus for the next class, right? So that should be it for today's class. I think so. All right, so we also have size, right? So df.size will basically show us the size of our data frame. So it has 12 values, right? So the same thing as NumPy array. So, all right, okay, let me just quickly go through this. I think we have some other attributes. So we have df.t. Please, can someone tell me what that df.t does based on what we've talked about in NumPy? What will this df.t do to our data frame? I need your responses. Exactly. It's going to flip the rows and the column. So we have our data frame to be this, right? But if we do df.transpose, it's going to flip it. Have you seen what it did now? It brought the columns to this row and it brought the rows up to the column. So it flipped our data frame. So I feel you appreciate or you understand this transpose better with the data frame than with NumPy array, right? So that is it for that. And df.values, this is going to actually return a list of the values for each column. So for the first column, we have these values, right? For the second column, we have this. For the third column, we have this, right? So that is it for the basic attribute of the data frame. And I hope you understand the basic data structures we are going to be using in Pandas for the rest of the our time here, for the rest of the program, basically, right? So even after the program, this is what we are going to be working with. So you just have to understand this series and data frame. Next week, we are going to enter into the main operations we can perform on support series. And although we've talked about series, we'll now focus on data frame, right? The basic operations we can perform on data frame, right? And a lot of other things, right? So that's it for today. Basically wanted to introduce Pandas to also have an idea of what we are going to be doing, right? So this is Pandas for data analysis. And, we've come to the end of this class. So this is going to be a time for questions. All right. So if you have questions, you can just raise your hand, and I will take them. All right, Timothy, you raise your hand. You are allowed to speak now. Temitope, I just unmute you. All right. Moses,
I'm
you can
sorry,
go
I
on to
think I
speak.
raised my hand by mistake.
Okay, okay. All right, Moses, please, you can go on to speak. You are on mute.
All right. Good evening, sir.
Yeah, good evening.
All right. I appreciate the class so far. My question is on the first. When you started the class, you were talking about our curriculum, and I want to say that the curriculum I have is for data analytics. I don't know whether the curriculum for that data analytics is the same as this for data science. If not, then I don't have this one for data science so that I can go through what we have. Then my second question is when we are talking about to round up a number. We said if we want to round to two decimal place, we'll put two. If we want to do it for one, we'll put one. Okay, in the place where we want to round it up to a whole number, are we to put zero inside the argument? If we want to round it up to a whole number, maybe there come a time, a need for us to round it to the nearest whole number and not one decimal place or two decimal place. What do we put inside the argument there? Thank you.
All right, that's a great question. So if you want to round up to whole number, you
Yeah, to the
don't put
nearest whole number.
yeah, to nearest number. You don't include a number after the number that you want to round up. So it's going to be something like this. All right, let me just load. So it's going to be something like this. You want to round. Okay. So you want to round, let's say 67.652, all this number, right? So normally, if you want to round it to decimal place, you just put 2 and to give you this. But if you want to round to whole number, you don't put anything after the number. You just put round and you see it will round to whole number. So you see it will approximate it. You remember the integer function we talked about before, it doesn't approximate. Like that is not, you are not rounding up. But this one is rounding up. It will approximate this number to the one before it, and you get 68. So that is just it for that. So for your question,
Okay.
second question,
My first
this
question.
first question rather, the question was actually addressed a long time ago. So most of this the data analysis course, I believe Ibote was able to talk about that because I'm not the one that created this, so I'm not in the right position to give you an answer for that. But I believe someone asked this question previously, and I referred them back to the facilitator. They've already made they've actually clarified themselves on that. So you can always go back to the facilitators when you have questions as regard the organization of the program, right? So the questions I would be expecting are usually questions that pertains to what we are teaching, right, and the course particularly. So if it refers, or if you're referring to the whole program and the organization and some other things, I can answer some of the questions, right, if I have answers to that. But this particular one, I don't think I'm in the right position to answer that, right? So you can just reach out to the facilitator or the community manager, and they'll give you the appropriate answer for that. Yeah, so thank you.
Thank you.
Hope I answered. You got
You
cleared on.
answered it, but I think you are teaching us, so you should know you have the curriculum for data science. Now that's what I'm asking.
Like, yeah, I'm teaching you data science, right? So if you have a curriculum aside data science, I don't know how you got that, right? It might be a mismatch from the facilitators or people that are organizing it. So I'm supposed to be teaching data science here. So if you got a different curriculum, I don't know about that. I don't know how
Sorry, sir.
you got.
I presume it's a mistake because the instructor on that place is Emmanuel Annie, which is you too. Oh. The person taking that data analysis, the name that is there is you.
Yeah, so yeah, the thing is that the answer they gave was that what we are going to be doing instead is going to be data science. So we are the data analytics course is not going to, at least for this first cohort, we're not going to be doing that. So we are just going to be offering data science for now, right? So if you are still going to be interested in data science, then you can move on and then continue with us. But if it is data analytics that you actually came for, and you don't want to proceed with data science, then fine, you can probably wait for the next cohort, or I don't know, you can just um, exit the program, right? So
No, no,
that's
no, no,
just,
no. I'm not existing. I'm already into this one and I love it. It's okay, sir. Thank you.
yeah, exactly. All right, so is there another question?
I think what you want, you need the curriculum, right?
What do you
You
say?
said?
Hello. I think you need the curriculum, right? We'll send just ask any of your classmates there to send the curriculum to you. They all have the curriculum for the data science. They will send it to you.
That's exactly what.
Okay, so
Thank
you
you.
can go through it.
Yes. David, that's what I'm asking. Thank you. I'll
Okay,
ask them.
okay, okay. You're asking for the data science curriculum.
Yes, sir.
Oh, okay. It was not, I didn't get that. I was thinking you had an issue with what we are currently offering, and it is not matching with what they sent to you.
Not
So,
at all, sir. Not at all. I need the curriculum for this data science so that I can go
okay.
through it and match it with what we are doing.
Oh, perfect. That's not a problem. The curriculum will be sent. It's already on the group chat. If you go to the materials and resources, if it is not, we'll send it there. That's actually not a problem. So I was
All
actually
right. Thank,
mistaken.
thank you, sir. Thank you.
All right. So yeah, Philip, you're on mute now. You can go on to speak.
All right. Can you hear me?
Yeah,
Hello. Good evening, everyone. All right.
yeah, I can hear you. You can go on.
Yeah, I know, I can hear. Now, thank you for the question. I just wanted to confirm something. When we were talking about those arrays there and the other ones there. Now,
Please, can you speak
for the
up?
one, can you hear me?
Yeah, I can hear you, but your
Can you
voice
hear
is
me?
faint.
All right. So I was contemplating in terms of, let's say, checking the data types. I would like to know which of them has how to check rather the one with a higher precedence. Let's say, like the one you did the other time, there we had integer and a string, and the string actually it overshadowed the other ones there in that particular list, or rather the array there. So in yeah, and in terms of emergency also, how do I check? Is there a way I can actually check for which of the data is of higher precedence? I don't know if you get the
Okay.
question.
Yeah, I got a question. So there's there's actually nothing like higher precedence when it comes to data type. The reason why everything is converted to a string is because you can actually let me see if I can see that. All right, so in this case now, let's assume we have a string here. I could just put this Python. So this is the data list that we're trying to create as a series. So we have a string data here. The reason why everything is converted to a string is because NumPy will try to see the best conversion for each of these data. So it will come here and say, okay, let me try to convert everything to an integer because or a float, because a float is the best data type for this kind of operations, or yeah, whenever you want to do numerical operations, right? So it will come here and try converting 3 to integer, sorry, to float. It's possible. 4 to float is possible. 5 to float is possible. Then Python to float. So it reaches here and it throws an error like, oh, it's not possible to convert Python to float because float is supposed to be a number, right? So it's not possible to convert it to a float. So it is going to have to start again and try again. Okay, let me try converting it to a string instead. 3 to string is possible, 4 to string is possible, 5 to string is possible. Then this string will be maintained. So it's going to look for the best data type that everything can be converted to. So there's nothing like precedence in this case. Do you understand?
All right, it's clear. Thank you very much.
All right. Thank you very much for pointing that out. So, Omalade, you are allowed to speak.
Okay, good evening, Mr. Emmanuel.
Yeah, good evening.
Sorry, in the series, I tried running it on my system, so it keeps saying I didn't specify PD. What
I
am
did
I
what?
doing wrongly? I didn't specify, as in the error it was bringing out. It says I didn't specify PD.
Did you import pandas as PD?
Yes, yes. I later imported pandas. So I was trying to do the series part of it.
Okay, what exactly is your syntax? What do you use to create this
Just
series?
the example you gave in class, but the thing was I was a little bit distracted at the beginning of the series. So I just imputed all the values and I tried, using the link space, the way you've used it. So it
Okay.
wasn't working.
So the thing is that I would have to have a visual. I would actually have to see your error to be able to know what the problem is, right? So if it's possible for you to just send a screenshot to my DM, then perfect. I would look at it and then help you with that. Because I don't think I can infer from what you're saying what the actual error is, because it could be anything, right? So please just send me a screenshot and we'll figure that out.
All right. Thank you.
Right. Yeah, you're welcome. So David, you can go on to speak. David, you are on mute now. Please go on to ask your question. Okay. Ademoye.
Good evening, sir.
Ademoke. All right, David. Ask your question.
Yeah, I just wanted to ask if our index in a particular question is up to like we have up to like 100 index and we want to rename them. No, it usually starts from zero. So if you want to rename it, let's say the index from one to 100, how are we going to do it?
Okay, I'll ask you that question back. Okay. Based on what we've thought so far, what do you think is going to be the best approach? Let me just give you an hint. Remember how we talked about creating a sequence of numbers in Python. So how do you automatically create sequences using NumPy? Can you remember?
Um,
np.range. Remember the a range, np.arange. So if you have an index of, like, let's say 100 indexes, and you want to convert it, and you want to change it from 1 to 100, so you can pass into the index list
yeah, so
um,
one.
np.arange 1 to 101.
Yes. Oh,
Do you
yeah.
understand? So it
Yes.
automatically generate that list and then put it in that index. Do you
No, but
understand?
what I'm trying to say is this our series now. Like the index usually starts like okay. I get it now. I get it now. Thank you.
All right. All right. So any other question? Any other question? There's something I want to quickly do before
Good
we
evening,
round
sir.
up this class. Yeah, Ademoye, please go on.
Thanks for the lecture, sir.
Yeah, you're welcome.
Based on what we've been learning so far, I just observe from the NumPy, the array stuffs, and the data frame you made mention in Pandas.
Yeah.
You know, the data frame is a kind of visible working in real life stuffs like what we mingle with data and all that. But what is the most likely uses of those arrays? Or is it just for basic on how the system is built on?
Yeah.
Do you get my question?
Yeah, that's a good question. So, arrays are actually NumPy basically. Most of the time,
Okay.
you will not be working directly with NumPy, right? But when you get to in data analysis, normally you might not be working directly with NumPy. You'll be working with pandas, data frame, and series. But when you start doing machine learning, when you start doing machine learning, we now start
Okay,
using
sir.
NumPy arrays. So you see the application of NumPy array directly, right? So that is
Okay.
a very,
Okay.
very common application of NumPy arrays. But for Pandas
Thank you very much. Thank
analysis, use data frames and series. Right. So any other question?
you. All right. All right.
I'll
Thank
take
you
one
very
more
much.
question.
I
Yeah,
really appreciate it. All right, sir.
I'll take one more question before I do what I want to do now because we're already running out of time. Any other question? All right, Mohammed. So please go on to speak. I want to ask a question. I can hear you. You can go on to
Hello,
ask your
sir.
question.
Are you
Yeah.
hearing me, sir?
Yes, sir.
Hello, sir.
I can hear you, Mohammed. Please go on to speak.
Are you hearing me?
Yes, I can hear you loud and clear.
Yes, sir. Please, my question is in respect of those who don't have the laptop systems and they cannot also install the Anaconda on their phone systems. So, what will be their fate with regard to these lecture presentations that is going on now?
Okay, so that is actually going to be a difficult question for me to answer because it is highly recommended that you have a system for data science, right? But alternatives have been provided in the group, right? So you can look it up. You can ask your classmate or the class rep. You can meet Yusuf or Chukudi. They can direct you on how to use your phone to do all that we've been doing so far, right? So, but in the long run, you realize that it's not going to be efficient because there are some things we'll be doing that you require some other things, right? So, just try as much as possible to get access to a computer or a laptop, right? So, it's going to make everything easy for you, right? So that's just it. I can't really tell you exactly. I can't really tell you that there is a very good alternative aside the laptop, right? Because this is what you would most likely be using to do most of your work. Yeah. So yeah, that's it for that. Right. So okay. So let me just quickly show something. So I was trying to do this the other time. I don't know why um um Pandas was given an error. So for np.random.run, so you can easily just put the question mark, right? The same way we did for other things, and you see the explanation for everything, right? So you can just read that up. I wish I have enough time so I can tell you how to use this very well because a lot of use cases for this. You can do rand n, right? To show you this, you can do rand int. It will show you. So basically, this is a way to learn directly from your Jupyter notebook. You don't have to start going to Google and checking all this. So you can just put question mark at the back of any function you want to know, and it will show you a lot of information. So that's just it for that. So quickly, I want to show us something. Now, I sent this particular link to the Google Classroom. This is a visual description of NumPy, right? So if you go through this, you see an explanation with visual representations of arrays. It will give you a very good understanding of what arrays are. Like, I don't know how many of us have gone through it, but I know I sent this to the Google Classroom, right? So if you can see this, let's just look at some examples. So this is an NP array that is created. So this is basically how it is structured, right? So that's just the basic one. So you can see this let's see this. So this is how you create arrays, right? np.ones, np.zeros, np.random.random, you see, the one that I talked about, right? So this is operations that you can perform using arrays. So this array plus this array, element-wise operation to give you this one and to give you three. So these are just a visual representation. It will actually help you appreciate it and understand it more. So these are operations that you can perform on arrays. So this is broadcasting. As you can see, this array is multiplied by this particular scalar vector, scalar quantity. So what happens is that Python broadcasts this 1.6 to match the shape of this particular array, and to give you the following output. So as you can see, this indexing. So if you index 0, it will get this one index. So this particular website, I posted the link on the Google Classroom. So if you scroll down, to, let's say, I think the last week's session, that is week 3, session 6, yeah, section 6, you would see the link to this and another particular website. So just go through it. Just go through it. You would enjoy the explanation, right? You would see it and you appreciate it very, very well. So my aim for everyone here is to understand, to help you understand this thing perfectly. So it will be so easy for you. So people say data science is hard. Data science is hard. Like whenever you mention data science, but in reality, it is not hard. You just need to take your time. You just need a very good approach to learn the concepts, right? I believe that people that have been following up to now can boldly say that at least they've gotten to a level of working with Python comfortably, right? And that is just how it is. So it is not hard. You just need to put in the required effort, right? So this is, I just wanted to put this so you can see exactly how operations are being done, right? And something that I just want to quickly say that arrays, I usually talk about arrays. So one-dimensional array is called an array, but two-dimensional arrays upward, they are called matrices. Like, so that's a mathematical term. So you can either call it arrays or matrices. So in case you see it somewhere else, don't get confused. So that is it for that. So please just go there and look at it. And please read your book, read the textbook. Very, very recommended. Read it to help you a lot, right? So, and on YouTube, if you go on YouTube and check our videos, you see that each video has a description. So it tells you exactly what to expect from that particular video. So please, just all these things are things that will help you to learn better. Right, so we've come to the end of this class and I really enjoyed it. I don't know if you did too. So you can just let us know in the group chat if you enjoyed the class and what you learned and just drop reactions there. Right, so that is going to be it for this class. Right, we've finally come to the end of week 4. So congratulations to everybody. We've made it into the first month. We've done 8 sessions so far, and I'm actually really proud of everybody that has been consistent up to now. I believe it's your commitment would definitely has paid off. Like at least you've grown from a place of novice to a place of you are getting to at least understand Python and how to work with some of these things. So I would say congratulations to all you all, and we actually still have a long way to go, but we've also come far. Yeah. So see you next week on Saturday by 3 p.m. and expect your assignment to either today, this night, or tomorrow morning. All right. So for the new student, I'll be dropping week 3 assignments and week 4 assignments too. Right. So I'll be giving you enough time to do this assignment. Right. So right. So that is it for today's class. Please enjoy the rest of your day and thank you very, very much. Right.